All right, I'm going to minimize this and turn this over to Barkha, our special guest. Thank you very much for joining us, Barkha. I really appreciate this. And I know before I let you go, you told me what this is going to be about, but you had also leaked out that you were pretty well versed in blockchain. In fact, you've been in that email thread talking about performance being slow and log management. And I appreciate that. So if I pick your brain a little bit more on blockchain toward the end, I hope you don't mind.
Oh, I don't mind. Yeah. And I'm not an expert, but I will help you in any way that I can. So.
Yeah, we'll just see what comes along there. But
yeah, expertise takes a little longer than, I've done things for 25 years and other things for 1 or 2 years. So.
Understood. All right. Without any further ado.
So, hey everyone. So my name is Barkha Herman. I work my daytime job, more than 25 years in technology. Right now, doing a lot of DevOps work, and large projects, big corporation, big projects that I can't really name. And the last couple of projects that I've worked on were Azure focused. So you have to excuse me if this presentation is a little Azure focused. So, but it's a long-term background. I do come from the POSIX world. So.
Well, if I can interject, they're going to get a lot of questions on cloud stuff. So I think it's very appropriate. Right.
So, so I did my CISSP more than 15 years ago. So I haven't been involved in the the newer tests or anything, and cloud happened since then. So I don't know what kind of I'm not familiar with what kind of questions are asked. So I'll do my best to answer as much as I can, and we'll I'll try to incorporate answers also as we go. To improve my presentation as well. So, okay, so today's presentation is more focused on risk and control. And this is focused on Azure DevOps, but this is applicable to any cloud platform DevOps. And I think that the audience for this was more in terms of, when a team is wanting to go to more of a cloud-based operation, there's a lot of teams that are kind of outdated. So I'll give you an example, a very simple story. We were going through some, risk and control teams that were evaluating our deployment, and one of the questions that they kept asking was that, how many tape backups do you have? Where do you store your tape backups and all this stuff? And we're like trying to explain to them that this is a cloud operation and we don't do tape backups. But it was really difficult because that was one of the check boxes that they had to do. And so times are changing, but some of the corporate audit and security teams are not changing as fast. So you just have to kind of deal with it as you go. So these are the things that I'm going to be covering. I'm hoping to cover. There's a lot. This is a very broad topic. So these are types of things that we kind of addressed in this, one of my latest projects that we worked on. These are the sort of the categories of risk and control areas. And usually the standards are different based on which industry you're in and which corporation you're dealing with. So I try to keep this slide as generic as possible. However, these are just examples of the controls that are presented, the areas in which these types of controls will show up, and what, how you can kind of address them in a cloud situation. So environment, code, data at rest, data in motion, and monitoring and response are the categories. So Again, environments. So what I mean by environments is, and by all means, ask questions. I'm not seeing the chat box. So just,
Oh, there should be a thing at the, I'm monitoring it. So far, no
okay.
questions.
All
but,
right. So if you see something interrupting,
I sure will.
feel free. So environments is, obviously when people are developing on their own laptops or say their VMs or whatever, they can have no HTTPS, password is password, all kinds of stuff. You can do whatever you want within. But when you go from that to say a QA environment or a UAT environment or a, pre-prod sort of environment, or a staging environment or a production environment, of course the controls change from environment to environment. And before cloud, it was, it was kind of, it again depends on the corporation, right? There would be in-house solutions for all kinds of segregation. In some cases, you have a very clear segregation between production and pre-prod. Deployment slots are very well-defined. You can only deploy at certain times. You have to have approvals in place and all this stuff. On the other hand, you can have Mickey Mouse deployments where developers have access to production servers, and it all depends on who's best friends with who likes which, gets along with what. So, well, cloud is slightly different. So we're gonna look at some of those things. So these are some of the sample controls. You need to have logical and physical segregation of environments. The lifecycle methodology should be well defined, and there should be a process set for approvals and reviews. So approvals are before deployment, reviews are after deployment. So in Azure, the way we would do deployment. So so for instance, we would do, and I'm using a couple terms here that that are very specific to Azure. So PaaS is a platform as a service. IaaS is the infrastructure as a service. And basically the difference is, IaaS is a, you deploy a VM, and the virtual machine could be Linux or Windows or whatever flavor, and it could have all kinds of things. And anything that's not a operating system based stuff is a PaaS. So, drives, networking appliances, anything unrelated. Or in Azure, you have things like shared servers that are also PaaS.
The way they're going to be, if I can interject, the way they're going to be looked at, we're going to cover this, guys, in the next module, actually, is that and you've seen how I'm doing things. I have a hypervisor level thing. I'm using VirtualBox. And so I'm kind of like the cloud provider. And then in an IaaS environment, the client could load in their their operating system. They can load in their client OS. But in a PaaS environment, the way we look at it is they're not loading in the operating system. That's already provided for them, as well as other runtimes. But they can load in their applications. Is that compatible with the way we're looking at it here in Azure?
Yep.
Okay.
Yeah.
And then, so something that always puzzles people, since it's Microsoft's offering, they also have Office 360, but that's their SaaS model. That's where they offer you the applications as well, and all you do is use the apps. So those are the three platforms they need to know. So software as a service, which is Microsoft splits off as Office 360, and then or 365, and then PaaS and IaaS comes in as through Azure. Okay, fantastic. Sorry for interrupting you.
Perfect. Okay, So yeah, so that's basically it. And then we're using Visual Studio Team Services, which is their hosted version of source control, and also other, you know, it's a bigger than source control platform, but it has everything from tests to you know, work items to managing PBIs to build and release, and you know, everything in between. So so we have very strict policies on who can do what, and that's one of the reasons. That's one of the ways we implemented our controls. And then also we use deployment pipelines to control environment changes. So when we say environment changes, sometimes it happens that, hey, you know, we've tested everything. We've created a test server for, let's say, load balancing, and the load balancing server is not the same, configured not the same as the QA server. So the QA server is more, you know, QA team doing testing on just the functionality, the product working. And then on the load test, we soup up the server. Maybe the server has, you know, more CPU, more memory, more everything. And we've come up with some benchmarks, and it's awesome. And then we deploy it to production. And it could be that some environment variables, some parts of the load test environment are not one-to-one to production. So suddenly production and load don't operate the same way. Well, how do you control that? Well, in the cloud environment, you can actually create ARM templates, which are basically script files that stand up the environment from scratch. So there's no, you know, you don't have to remember, oh, we've originally deployed the production server with XYZ set of settings, and then, you know, something happened and we tweaked this setting and that setting. Basically, everything that's happening is we are actually standing up new IIS boxes or whatever resources, PaaS boxes or whatever, using scripting. So if we make a change, we change the script, we check it into source control, somebody approves it, merges it, you know, and then we deploy it using that. So there's complete transparency in what is going on, what changes are happening, and nobody just logs into a machine and tweaks it. So.
Oh, that's it. So it's always by script. It's never.
Correct.
It's never somebody who has like a telnet session or whatever.
Cannot telnet and do anything. Nope. So you cannot go into the server, and nobody has access to that. Well, I shouldn't say nobody, but we have very few people who have access, and then all that is highly controlled. So, you know, a person who is, yeah, so it's monitored and controlled. So you can't just randomly log into a box and edit or tweak anything. So here's an example of what a, you know, the script code looks like. So this is just a sample that I did for one of the demos. So basically, this is a script file. It is a PowerShell script with some JSON that describes what happens. So the JSON blocks, there are parameter files, and then there are some other JSON files. So this example has a website database and also a website parameters. So you can have multiple parameter files. So for example, you would have a different parameter file for the dev, you know, the shared development environment or the QA environment than a production environment or a load environment or something like that. So that's pretty much what this is. So all of this is actually script files. They all follow, they are all checked in. Once they're checked in, there's a build created for it. So let me show you that. So this is the VSTS. This is the Visual Studio view, and this will actually, this is where it's checked in. There's actually a build that happens to this, and then the deployment pipelines actually do the deployment. So you can have, so this is the continuous deployment. The first one is CD, is a continuous deployment development environment, where we as DevOps team can test the environment, standing up an environment. So we can actually stand up as many environments as we want, and we can test it.
In the development area. Now
Correct.
I see you've got approvers set up for each environment. So
Correct.
explain to us a little bit more about the difference between the QA approvers and the prod approvers.
Right. So for instance, the CD environment, you know, we actually have our own sort of playground, because we want to test the environments also, right, as developers, because DevOps is the developer for this product. So we're actually making the scripts and we're playing with it. So generally speaking, there's 1 or 2 approvers within our own team. Now the QA approvers, it could be that QA is running a whole bunch of testing, and we want to deploy something or upgrade something, and that doesn't happen. So a couple things. So for instance, let's say that we have a huge project with more than 200 developers, and somebody decides that, oh, by the way, in this sprint, we're going to add a new feature that uses Redis cache, right?
Mm-hmm.
Well, the environment doesn't have Redis cache. We need to go edit our scripts, add whatever needs to be done to add the Redis cache. We can now actually make it so that that code is dependent on this environment script. So while dev is ready for Redis, QA is not ready, because QA is still testing the previous sprint and they're doing something with it. But they want to control when their environment gets upgraded and the new code gets deployed to it. And so when we define, well, you know, and in BSTS, what we do is we just create groups. So, and then for policies, we set up group policies that says, oh, you know, we need at least 1 approver from this group and at least 2 approvers from this other group. So for instance, in QA, the approver would be somebody from the QA team, or, you know, sometimes they want more than 1. So it could be a QA lead, or it could be a QA team member, or however they choose. And then, of course, one of the prerequisites also is that it must have succeeded deployment in CD, because you can't, you know, deploy directly to QA. You have to go through the steps.
And
So
I'm sorry, help me again. Is CD, it stands for?
Continuous deployment.
So am I getting it right? There's actually 2 testing environments. There's the
Correct.
CD environment, then there's the QA environment, and then the prod approvers are before it actually goes into actual operations.
Correct. So there's a prod group. Very typically what will happen is there's actually a separate subscription for prod. So, you know, cloud environments are subscription based. So usually the pre-prod subscriptions are very different than prod subscriptions. So the deployment for prod will be in a different subscription, a cloud subscription, because developers don't have access to that.
Right.
QA doesn't have access to that.
Well, it sounds like developers shouldn't even have access to the QA environment.
Correct. They don't have access to the QA environment, but they can look at, you know, what version went in and things like that. So they have.
So let's say we're doing some healthcare or anything that is PII.
Right.
There would be no PII in either of those 2, either the the CD environment or the QA environment. You would not actually have PII in that. You'd have some sample data.
Correct.
But once it goes into prod, no developer should ever even see that.
Correct.
Because they're not a valid user. I see. Okay.
Yeah. So I mean, it's really convenient, and because of the fact that we can stand up and environments and we can script them, we can automate them to this level that this is even possible. So, you know, we have these pipelines created for deployment. And the good news about this is that if you look at this, it actually deploys the same script. So there's no change between what gets deployed to CD, QA, and prod as far as the script is concerned. The parameters are different, right? We talked about that parameters.json file, where, you know, you may want the CD environment to be much smaller less CPUs, less memory, whatever, and prod would be very different. But the code that's being deployed, so in other words, what resources got deployed is consistent. So we're guaranteed, a tested.
That the config is solid.
Correct. So.
Nice.
And then service principal names, SPNs, that's what it stands for. So we use SPNs for environment. So in other words, if I have this script, what is to stop me from running this script and running it against, say, CD or QA or prod? Because the script can run anywhere, right? Well, so what we do is the script can, in order to run the script, you need to have credentials. And so what we do is we set up separate credentials for each environment. So CD has a different SPN, and QA has a different SPN, and prod has a different SPN. So, and so when I am hitting the approve button in prod, well, I wouldn't be, but whoever is hitting the approve button, the person that's doing the deployment is a different identity. So.
Right.
That way, it's not Barkha that's deploying to prod. It's the service principal that's deploying to prod, and so on.
So that's a role of
Correct.
Authorization there.
Correct.
Different for each environment. And
Correct.
I'm so sorry, I'm a little thick-headed again. What does CD stand for again?
Continuous deployment.
Continuous deployment. Continuous deployment.
Right. Yeah.
So that's because you're constantly making changes. That's the most
correct. So every time there's a change in the script, and I check it in, and I'll go over that a little more detail when we talk about code, because this is also code. So we actually use the Git Flow process, and I'll show you what that means. So and then there are approvers set for each environment. QA approvers differ from prod approvers and all this stuff. So and there's all kinds of fun stuff you can do. So well, I'm gonna do a lot of demo towards the end, so we're gonna save the demo stuff towards the end. I'm gonna go over the code, control for code, and this is I'm always conflicted as to whether I should do code before environment, because we use some code principles in the environment deployments, but in order to deploy code, you first need the environments.
We have a question from Malika. She wants to know, how do you address developer versus developer segregation of duties? So two people in CD, I guess.
Right. So okay, so that's a good question. So,
versus deployer. I'm sorry. No. Okay. So that's the SPN. That's the.
Yeah.
Okay. So developer versus deployer. So that's
it's never a developer. Even in the normal, I'm hoping that even in the non-cloud environment, the deployment is done by DevOps and the development is done by developers. And the only place that the developer is allowed to put code is in source control. That's it. They're not allowed to put code anywhere else. They don't have access to anywhere else.
Yeah, if you can go back, I'm sorry, that slide with the SPN in there. I think that's maybe what she missed out on. So there's the second bullet. These SPNs are principals, you call them, that
right,
have
service
rights,
principals.
Service principals that have rights to develop in those and deploy in the various environments. So a developer would never be able to, without approval from QA, approve to the QA environment, and then they can't to approve the prod without somebody, a principal from prod okaying that.
Right. So you cannot hack it because you don't have the credentials for service principal. So you don't have access to the CD box in order to deploy it, right? And then there is the pipeline that does the deployment. So you could say, oh, well, I'll just run the pipeline, right? But the pipeline requires approvers. So as soon as you attempt to push to CD, an approver email will go out, and it requires an approver to push yes. So
and our second question is, I heard you say that they can have separate IDs. Are these also different people, or the same person with different IDs? And I think typically they would be.
So they're not people. People is a bad idea. Giving access to people is a bad idea. They are service principals. So they are separate
roles.
Identities that are created just with certificates, and so they're a identity that's created. Now, who has access to that service principal is So right now the service principals live as applications in Active Directory, and who has access to those is groups. So it's, the AD admin group will have access to create those service principals and give them the correct rights to each environment and subscription.
Is it
So,
safe to say that in a small environment, maybe one person could be a member of multiple roles, but it's not good?
correct, yeah. So, and that's why we create the groups, even in a one person, 5 people group. I would recommend you create the service principals and create the groups, and you can be in all the groups and you can do the approvals from all the groups. However, it's always a good idea to create the service principals so that if somebody else joins your, little five people party, it's still easier to, put them in the right place rather than giving a individual access to it. So
Yeah,
groups work
actually, for your test, Malika, it's an ISO 27001 requirement if you were ever to get certified, and they may actually use the term mutual exclusion in this case. So you would be mutually excluded from those groups. You could not be a developer and a QA person, or in our case, they might call it a tester. You cannot be a tester and an they'll say an operator, but that's like the prod approver. So they are mutually exclusive roles, and there'll even be the questions around that. Yeah, that's what you're trying to get to. Okay, that's what she's alluding to. Awesome. All right, so I think what Barkha's showing us is the capability. How you configure it is up to you, and the best practices to follow.
Yeah, and for each organization, it's a different policy. And when we go through our risk and control assessment, we actually have to, the auditors will come and take a look at all your group components and say, okay, who's this person? Where are they in AD? How did they get into this group? And all that kind of stuff. So,
great.
But that's more
Thanks,
Active
Malika.
Directory than really cloud. But this is more cloud based capability thing. So moving on to some controls related to code. So obviously the code is located in a secure location. Access to modify the code is restricted. Code is reviewed, tested, and scanned, etc. And there can be more. And then code deployment is gated and audited. So this is the point that I was trying to get to in the previous, is sometimes it's easier to understand the deployment of environments if you understand the gated and audited part of code deployment. So let's take a look at this. So we use Git Flow and branch policies in VSTS. The idea is that we build one and we deploy several for consistency. So the build that's created is deployed to everywhere. So it's deployed to CD first, and then QA, and then whatever production. In our little example, we just had 3 environments, but typically you may have more. You may have a staging environment, you may have a load environment, you may have a UAT environment, or who else? Who knows?
Oh, so the UAT might be separate from. I was thinking that's what the QA was.
No. So typically what happens is that QA is a functional, quality assurance.
Mm-hmm.
UAT is actually end users. So UAT may be, so what happens is, so we do Agile development. Obviously the company is called Agile Thought. And in Agile, QA is part of the development team. And so for every sprint, which could be 2 to 3 weeks, in our case it's 3 weeks, we create a piece of software that's shippable. So during that period, QA works with us to do quality assurance, so functional testing for everything that we produce. After the sprint is over, the code goes into another bucket where it's tested by UAT, which is the actual stakeholders. So these are non-technical people, real users of the software, that'll actually do user acceptance testing. So that's not the same as QA. QA is functional testing.
Yeah.
And also, this is also the time where they do load testing to see if we met the load testing targets, because it's very difficult in a 3-week period to do functional as well as load at the same time. And we're able to do some load testing, but it's, the load testing post-sprint is typically in a more integrated environment.
So when we say on our CISSP stuff that the UAT is the most important test, would you say that's fair?
Yeah.
Okay. And we actually use the term, I'm sorry, we use that term as validations, that they perform validations.
Right. Okay. So we build one, deploy several for consistency and deployment pipeline with approval gates and audits. So let's take a look at what that looks. So do you guys, have you heard of Git Flow at all?
I have not.
Okay. So obviously, the source control everybody's using these days, Git. Git Flow is the process that they kind of introduced during, in Git.
Oh, and from GitHub and all that stuff? Is it from GitHub? Is it related to GitHub?
Yeah, it's Git related.
Okay.
So, but it's been adopted pretty much industry-wide because of the changes in Git. So, so you'll hear about this, and this is kind of important to understand for code security, and because we use code to deploy on cloud, also environment security, right? So we use Git Flow. Git Flow, this is the way it works, right? So you have your the develop branch, which is the main branch. And then every time a user makes an edit, so let's say I'm developer A and I want to make an edit, I never edit the develop branch directly. What I do is I create a branch, I make my changes, and then I I submit a pull request to merge my branch into develop. So the pull request triggers approval requests, and it has to be approved. Usually what happens is the rule is we want more than one approval, and the approver cannot be the coder. So usually what happens is two developers will review it, and they'll do code analysis, any style issues, anything, they'll put comments on it, and then you can submit it, and you can take it merges into develop. So
I'm sorry, I keep getting these because I know they're testable objectives, so I hope I don't disrupt your flow here.
Yeah, no.
But the code that you're developing, I take it could be either scripted languages, your whatever, Python or Ruby, but it could also be C or some compiled language.
Correct.
Now, what they need to know for their test is that it's very important that before we do any fuzzing or any of the post-compilation testing, we want a third party looking at that source code. Particularly for their test, they want input vulnerabilities checked. So where does that happen here?
So right now, so there's a couple of ways of doing that, right? So the PR process, the pull request process, does it by default, so that every piece of code that's merged is done. It has more than one eyeballs, right? So I cannot, as a developer, just make a change and check it in. It has to go through the PR process. So that is
a lot of my DoD guys. They'll bring in a third-party company to actually do that code review. So they'll bring in Booz Allen is very big.
And those can be automated also. So the third party can actually get an email every time there's a piece of code that needs to be merged.
Fantastic.
And they can just review it, so that they can be part of the PR process. And then typically what happens is before we deploy the code, we actually have a scanning process that runs on the entire code. So that's part of the deployment process. So what we do is we scan the code for any, and especially in today's day and age where developers are using a lot of open source stuff, right? Well, open source is great, but how do you check for security on open source, right? How do you
we have a question. What does PR stand for? And is that
pull request? It's number 2, the bullet item 2, pull request.
PR. Pull request, PR.
Correct. And so this is Git technology, Git terminology, but it's kind of become very mainstream. So this is something that would be good for everybody to know. So so yeah, so if your company does not adopt this, you should. Okay, so so it's not just the code that's being checked in, but also references to any compiled sources or JavaScript libraries or any scripting libraries that we're referencing that we just get from third-party open source places. And for that, we do use some third-party companies that provide that service. And yeah, so, and they do scanning of the entire code before it's deployed. So okay, so moving on, number 3, developer code lives in PR branches, merged into develop. The master release, which is the kind of not the red, but the pinkish, that is the master branch, and that is merged to only after a release. So if we push anything to production, that's the code that goes in master. So the development branch is always continued on. So code must compile before merge to develop. Build runs tests and scans for issues. So this is the point where we actually run any scans that are either vulnerability, and we can do, there are code scanning technologies that are extremely smart that can detect all kinds of vulnerabilities. And also, this can either be automated or be manual. So, and then deployments are gated. So.
Gates are something that would show up in the near future too. So we talk in our class about gate reviews and the keeper of the gate. Could you explain a little bit on what you do there?
So in this process, in the process that we are using to do deployments, you can have gates that are as simple as always have a 15-minute delay between approval and deployment. Why, you ask? Because sometimes we send out approval emails and people just randomly click, yeah, I want to approve. Or as complicated as, we need to check that the source has no debug files, the symbols, the source came from this repository and not that repository, all kinds of fantastic things based on, your kind of process. So builds cannot be done based on developer branches, which is the little green thing here. They should be off of the main develop branch, things like that. So those are gates that we could create, and also approvers. We must have 5 approvers. It must be this and that. The tests must be 90% coverage or 100% coverage, code coverage, things like that. So.
Cool.
Okay. So this is a representation of the deployment pipeline. So the build process creates artifacts, which could be anything from the compiled files, scripts, images, documents, data, or anything. So when you were saying things like PII data, the artifact for a production environment would be different than what's in QA and things like that. So build artifacts are created once. Then what we do is we do deployment. So the continuous deployment ensures that every time there's a build, we compile, we test, we scan for vulnerabilities, we do any of our little testing that happens for every build, so that as soon as there's a build, we find out if there's any upstream issues. So that's why we always set up a CD environment. The QA usually is on demand. So QA decide, the QA team decides when they want a build to QA, but it has to have passed CD in order to get to QA. So, and also there's a post approval needed from CD to QA. So in other words, once it goes through build, it goes through all the test runs, it goes through scanning for vulnerabilities and reviews and all that stuff. QA needs to say, yes, this is ready. We're satisfied with the CD build, and it is now okay to go to QA. And there's a whole process. Usually there's at least one person who reviews the CD build and says this is okay to promote to QA. And then it also requires one or two other approvers to say, yes, we're ready to take this build to QA for whatever reason. So that's the gate there.
All right, we have another question here. How are vulnerability scan results addressed? At my company, it is hard to track them in risk register due to volume and remediation plans. Any suggestions for them?
Right, so basically if you actually create a step that says that, so I don't know what tools you're using.
Say it's Nessus.
Yeah, Nessus is one and VeriTread is the other one that we use. And so we actually run the scan, and basically it is a pass or fail. And so what happens is you can either set it up to be a manual pass or fail or automatic. And VeriTread actually gives us a result that automates that. And I think one of them, and I forget if it's Nessus or not. So what'll happen is that it'll run the scan and send the result to whoever the group is that needs to review it, and they have to click OK for it to go to the next step. But if they don't click the OK, then it's a fail, and then it cannot be deployed. That build cannot be deployed to QA because that's one of the gates. And I'll walk you through that so you have.
Yeah, I'm just curious as to what she's alluding to, because she said it's hard to track them in a risk register due to the volume. So it seems like she's getting a lot, and it's just hard. Is there a point where you just go, you know what, there's too many, we'll just create an umbrella thing for it and just say, it goes in that group and under one.
Yeah, so this is the challenge, is that, we can put process after process, but it has to be something that's followable. Otherwise, the process just is useless, right? So for us, where we do, we have nightly builds. So the CD build is continuous, but we have nightly builds that must address the scan. So before it goes to QA, it must go through those gates. So the group that reviews the scan has a once a day, dependency on them. So they must approve it. So that's what we do. And if they don't, then it doesn't go any further. And then, and it's a huge team. Like the project I'm working on is huge. And, you don't want to be the bottleneck. QA, 30 people in QA are sitting around doing nothing because you were too lazy to say yes.
I'm reading this thing, I'm trying to follow. It says, for us, InfoSec scans, but infra or development teams have to address. So OK option wouldn't be trusted since they would have the incentive to just click OK.
Right, but it wouldn't be the QA, the developer that gets that email. Typically what needs to happen is that, so here's what would happen. If it's a sprint issue, so we're in a development sprint. Of course, we're not going to stop all development to fix a Nessus flag to say nobody can do any more developments or nobody can QA anymore because there's a red flag. Typically what happens is we have a team that is assigned to risk, right? This kind of risk. And that person, the team lead for that person, reviews all those scans. And then what they'll do is they'll classify it as a critical or not. And 90% of the time what'll happen is that it just results in a work item of severity 1 for the development team saying, hey, this is a Sev1 bug that the product cannot go live unless it, it's done this. So that's how they would address that. And so yes, it'll still go to QA, but it won't go to prod because there's a sub1 bug against it. And so one of the gates from QA to prod is no severity 1 bugs. So that's the other thing. And so yeah, that's one way to address it and continue the flow, because we don't want to stop. You know, you have a 200 people team, you don't want to stop everybody's work because there's a big issue, but at the same time you want it to be also addressed in the proper way. So we have a once a week meeting for nothing but security and performance issues, and so those items are brought up during that, and then we track progress on it. Does that make sense?
Yeah, I guess in my limited thing, and while I'm waiting for her to type in her reply, but I'm thinking, imagine the problem was due to some library that say Microsoft or whoever created that has an input vulnerability or whatever.
Correct.
And that's going to be constantly used in the constant deployment model anyway, to say, hey, it keeps coming up with it. Yeah, we're waiting for this thing to be fixed. So it's not going to get deployed until that is. But in the meantime, let us continue development, and then when that thing's fixed, everything will get fixed or something like that.
Correct. Correct.
Does that seem to, Malika, does that seem to answer your question? Excellent. Okay, great.
Yeah. Yeah. So, I mean, there is a way to track it. And that's the whole thing is, I know there's the saying that watched pot never gets boiled, but the only things that we measure get fixed in software development.
Yeah. We use that term all the time. I'm a sniffer guy. Most of my consulting experience was in protocol analysis. And we always say you can only speak matter-of-factly about what you measure, but you can't measure everything.
Correct. Yeah. So if you create a process that addresses that scan issue, then it's dealt with.
And for my students, a little quiz. What's the maturity level in CMMI addresses measurement? Very testable. The guy, hey, we got it. Chad has got it. Excellent. We got a few people got it right. All right. Awesome.
All right. So maybe we'll do a demo at this point, or should we? What do you think?
Oh gosh, time went by awfully quick.
Yeah.
It sure did. Oh, I'm so sorry. Well, I think we have time for a demo. You have something you'd like to show us?
Well, let's finish the slide.
Okay.
Let's finish the slide and then do it. So we didn't really get to all the areas I wanted to.
I'm so
I'll
sorry.
stay a little later if you don't mind to do a little demo so that you guys.
I think we can afford another 15 minutes or so.
Okay. Okay, so I'm gonna brush through this stuff because this is going to be very different based on which cloud tools you use. So, some of the sample controls and data. So this is data at rest, right? Ensure the data is encrypted at rest. And there's a lot more controls related to data when going through stuff than not. A lot more attention is paid because it's easy and quantifiable to see if data is, to monitor data. So ensure the data is encrypted at rest, access to static data is controlled and audited, ensure data is highly available, data is restorable, loss prevention, and then is auditable retention policies. So, this is where the equation is very different on the cloud than it is on an on-premise scenario. So here's an example for SQL. So this is Azure SQL uses TDE, transfer data encryption. So uses key vaults for encryption keys. So all cloud platforms, Amazon, Google, as well as Microsoft, have this concept of key vaults. And so this is good because, basically access to everything can be accessed by key vault we can actually make sure that, so for instance, data access so in this case, we're using encryption keys for static data encryption, but we can ensure that nobody has access to that key vault except the application that needs to have access to. So in our scenario where we have a continuous development, the developer machine, so I have a local machine, my key could live in a key vault that's local, but the QA key lives in a key vault that's accessible only by the QA application. So even a QA person does not have access to, or a logged in user does not have access to the data unless the application serves it up, right? But in order to go directly to the actual data files, only the application who has a AD Active Directory identity has access to the vault related to that data, and it can encrypt it. So that's a added way of
Are these in the form of
securing.
certificates? Is it?
So it can be a certificate or a key. It depends. So if it's an encryption key, then it's a key, or
It's
if
the
it's
actual session key.
yeah, correct, yeah.
And then how do you change those keys? Because you shouldn't be using the same key over and over again.
So what we have is we have scripts that actually do key rotation, and then the scripts are run using SPNs. So I don't change the script as a
No,
developer.
rotation sounds like you might be reusing a key at some point. Is that?
So for instance, TDE uses a key, but you cannot. There's consequences to changing the key because the data has to be re-encrypted.
Sure.
If we change the key, so you can actually have Azure SQL provides a whole mechanism for changing the key for that because it also manages the encrypted data, so it has to re-encrypt the data. But if it's something like, so for instance, let's say that you have a client that has some documents that need encryption. So we would have encryption keys for the document, but we change the keys every 3 months. Well, we need to preserve the old keys for the old documents for audit purposes for a very long time. But what we may end up doing is we rotate the keys and re-encrypt some of the data using the new keys going forward, or whatever the policy is. But we still need the old keys for moment in time, snapshots, depending on what kind of organization you're dealing with.
And TDE again, it stands for?
Transport data encryption.
Well, if it's transported data, then it's not data at rest.
Yeah, no, I think I don't know what TDE stands for. Let me look it up.
Because this sounds like data at rest issues, which as a network nerd, I'm always thinking, you don't have to worry about the session key, just regenerate it. But that's for transmitted data.
It's transparent data encryption.
Transparent data. There we go.
Provides, which actually it's kind of, so all the files, if you copy the database files, they're encrypted.
You're right.
However, the program unencrypts it. So the only way to get to it is using the.
But for archival purposes, that has to be available for a long time.
Correct.
You can't destroy that data. Yeah.
Correct.
Awesome.
So again, this is an example, and it's a very lame example, but every sort of cloud service for data storage has a equivalent of something like this. So, and that's the good thing about anything on the cloud, is that there's built-in, encryption and everything pretty much. So here's an example. We have, let's say that we create a blob, and you have the option to enable storage service encryption. It's always it's encrypted while in rest, and then there is a corresponding key that even the user doesn't have access to. So only the storage service has access to. So there's a key somewhere that it uses to encrypt, decrypt, and it'll use it to do decryption and decryption. So.
Is there any way for somebody to log in as the service and then have access to that key?
No, because it's a cloud thing, right? So you can you can renew keys, and there's mechanisms for that, and it'll automatically re-encrypt everything, but you can't actually get to the the vault that has
So,
the key.
and I guess the advantage there is if somebody does need to decrypt archive data or whatever, the program does it, and the vault will always log access to that key. Is that
Right, and you can do a you know, end user version of it. So you can provide your own key if you like, and but you know, I would say that let the cloud deal with some of that stuff,
sure?
but it depends on the policy. Some companies require, and depending on which industry you're in, by law, you're required to manage keys as the service provider, and in some cases you can defer it. So requirements for somebody who's doing HR is very different than somebody who's doing, you know, financial services, than somebody who's doing.
I suspect you've had to bump across GDPR
Yeah,
in the last few weeks, and I imagine that would be if you fall under that, they probably don't want any human being able to get the key.
correct, correct. So it is a case by case basis, and both options are available. So, and this is just an example for storage blob in Azure, but it's the same across AWS and Google. So Cosmos DB is one of their, you know, NoSQL database. I'm not really going to go into case studies each per, because we're running out of time, and also there's just so much to it.
Yeah, and you just mentioned another thing I'm fascinated by that I don't know if the test covers, but NoSQL, very big today,
Yeah,
and I wish we had time to pick your brain on that, but I don't want to hold you up any further.
yeah,
You should just
yeah.
join me in this. That would be
Yeah,
wonderful.
we still have more ground to cover. So so the other thing is that, you know, you can deploy a VM without certs running on your web server or whatever, but you cannot do that for in cloud environments. You have to have TLS. So it's enabled by default. So you know, that's one of the good things about cloud, is it kind of forces you to use some good controls. Authentication and authorization is implemented everywhere unless you explicitly make it public. So it's you know, it's explicitly um, required to make things public. By default, everything is uses authentication authorization. Um, all communication is secure in transit. So these are the kind of the controls. So TLS is a default in PaaS services. So PaaS services, again, if you create just a website, or you create a SQL server, a NoSQL database, a, you know, whatever, Redis cache, any of the things that are not a box, a VM, TLS is default. ASCs can be set up for, so ACEs are private virtual networks within the cloud, which have an IP and firewall. And so in that case, you would have to punch a hole to get into, even for PaaS services. So that's kind of neat. You can have Azure site-to-site VPN. You can have Azure point-to-site VPN, and you can have ExpressRoute. And there's similar mechanisms available for AWS as well as Google. And ExpressRoute is a private tunnel between your organization, so your corporate infrastructure, and Azure. So those are some of the options that are available. And finally, monitoring and response. So the good thing, so these are some of the sample controls. All endpoints have logs for auditing. All endpoints have monitoring available. Alerts are set for disaster as well as security related events. Diagnostics are available for all services. So this is one place where I think that the cloud is extremely powerful, because they provide, you know, built-in logging and monitoring for all their properties by default. And, you know, that's one of the selling points of the cloud. environment, and they log just about everything. So so we can go into this, and each one of these can be an hour-long discussion. But
I
let's
wish
not.
we had the time.
So all right. So now let's. I'm gonna. So tell me, what are you seeing on your screen right now? Because
It looks like your PowerPoint, you know, you'd close the slideshow, but we're seeing the
okay.
PowerPoint app.
Okay. So let's see if you're a. Let's see if we can see.
There
Some
should be a way
demos.
to share. Yeah.
Yeah. I want to see if we can do some demos.
I know when I switch app to app, I have to stop share and then share again.
Yeah, let me do that. Let me stop sharing. Sorry about this, guys.
Oh, no problem. I really appreciate this. I just wish we had more time because you said a couple of things during there I was questioning. I wanted to know for the site-to-site VPN, or is it SSL, or are they doing IPsec, or?
So TLS is the
It is
technical
TLS,
term.
okay, yeah.
And yeah, so they do TLS for most things. And as soon as this.
And while she's doing that, I'll just explain to my class. We're going to be covering that TLS and SSL tomorrow. But basically, TLS is just what SSL4 would have been. So SSL was a trademark name by Netscape. And then when that trademark ran out, or that patent ran out, they, I think it was Microsoft stepped in and just renamed it to TLS. So, but if you're using Wireshark, you always put in SSL as your filter, and then you'll see TLS.
Okay, so I'm gonna try and do some of this stuff. So this is, I created this as a test account. I'm trying to see if I can bring up some. So this is VSTS. Here's a dashboard, and this is not going to be, you know, this is my
Personal
tiny
environment.
project, so it's not exhaustive. But I want to go over a couple things. So so things start out as, so first of all, things start out as projects. So I know we talked about a little bit about segregation. So this is a project. So let's say that, you know, you're working on a large organization, and the project team is divided into 4 or 5, depending on, who knows, back end, front end, or microservices. There's 50 teams or whatever. So you would have a separate project for that, and that way you could segregate your development team. So we're going to go into this project that I created. The work is actually the PBIs. So this is where you would create all the work to be done. So, you know, for instance, here's a user story that says update infrastructure template. These are all, you know, sprint related things, but and I'll tell you why this is important. Because one of the things that we do is we actually so here's where the code is. So here's a sample code, and this is basically the source control. It uses Git, so this is actually connected to Git as a repository. Here's a history of what happened, and let me show you how. So see this little arc over here? So this is what a PR merge is. So remember in Git Flow, we were talking about how stuff happened and then there was a merge. So this is the point where it actually merged. This is the pull request. So looks like there were 2 pull requests, and you can look at this and see Barkha has completed the pull request, blah, blah, blah. And then there were 2 approvers. There was Barkha, Herman, and Barkha, which is just me. You can take a look at the files that were involved in this pull request, everything that changed, all the changes, the updates, and commits that were made. So every commit that happened. So this is all related to just this one pull request. So this is why when Larry, you were talking about code review and scanning the code, this is what will happen. If I create a new pull request, you'll see that I'll get an email with this, and I'll be able to actually look at each one of the files. Now these are not updates, these are just adds. So if there was an update, it would actually show that, hey, this is the change, these are the things, and the plus indicates it's a new line. And it would show side by side what was added and changed and things like that. So this is where you would do a code review. So that's one. And I'm gonna do this real quick, guys, because I know I'm way over time. So now, well, let's go back to code for a second. And let's go to branches, and I'll show you what's going on here. So we're gonna say here's the branches, right? So this is where you would set branch policies, and let me know if you can see this. If it's too small for you, I can increase the.
It's pretty tiny.
Let's increase the size.
There we go.
So this is where you can say, now I can't change the branch policy, but I'm just showing you that there's a branch policy. It says that before merging, so in other words, you cannot change code in develop directly. What you have to do is you have to create a separate branch and merge into develop, right? And then it requires a minimum of 1 reviewers. So and then there's a flag that says allow users to approve their own change. Obviously, that's not checked by default. And then there's a couple other options. And then also there's a check for linked work items. So in other words, you cannot just randomly make a change because you felt like it. You have to have a work item that was defined in this work item, saying this is why I'm checking. This code change is related to this item that was requested of me. Does that make sense?
Yes, and it's actually going to relate to something we're going to say on Friday. So I'm going to invoke this step.
Right. So that's the second part of it, is that you can set all these policies, and also there are also build validation steps. So and you can have require approval from external services, and you can have the external services could be your Nessus and Veracode and all that kind of stuff. Or you can have a build validation step. In other words, what you can do is every time you merge code, you do a build, and if build fails, the merge fails. So you cannot break the build, in other words. Now, depending on how big your team is, this can slow things down quite a bit because you don't want things building and running scans all the time. So you may want to have a, so you have to decide how you set the policy, but that's the point, is that, you set up policies in such a way that there's never a, some random person wrote some code and it just ended up in some place. So that's one. And then let's look at the builds and releases. So let's go to build. And I only have one build. So this is my continuous integration build. CI stands for continuous integration. CD stands for continuous deployment. So you'll see that you can go and look at the, it failed once and it succeeded once. You can look at the success rate. You can look at what happened. You can look at the history and et cetera, all kinds of stuff. You can actually queue a new build and you can do all kinds of fun things. Release. So I'll just go into this release definition. I'll just show you just because.
We really got to close up in 5 minutes here.
Yep. And this you can see what so this one was canceled, but you can look at what were the artifacts. This was the build that was related to what tests were run, what work items were related to it, what environments was it deployed to, and the history. So all kinds of is tracked. Everything is available for auditing. There's a audit trail for just everything that happened in the system. So
if something were to like create logs, would that be, those logs fall under like artifacts? Is that how that would be? What explain us more artifacts?
No, artifacts are deployable things. So it's generally code and configuration.
I see. Okay.
Yeah. So code, you know, any supporting files such as images and JavaScript and scripts and all that stuff. So, but that's what, you know, and you can actually look at what the artifact is, and it'll show you what are the files that were deployed. So for every build, you can look at. So this was the artifact that was built. So I'm gonna stop there just because I mean I could go on for hours on this, but
yeah, and I would love to listen to it. We have a question from John. Barkha, how have coding practices changed in the last few years as far as security is concerned? I remember going through dev courses in security even as recent as 2009. It seemed to be a topic and not really a focus. Has the paradigm shifted? He's not a coder.
So yes and no. You know, I think that the ground level developer still is not that interested in security, but I think that the trend is towards using more frameworks, and the frameworks are becoming more mature. So as a result of the fact that more people are now using frameworks rather than just everybody rolling their own for every little thing, the trend is different because of that. But yeah, but if you talk to the average developer, they don't really care about performance, security, you know, control, anything.
Do you remember a term, extreme programming?
Yes, yes.
Now, in my experience, that has been mostly replaced with Agile. Was that seem fair?
Yes.
So that gives us more risk controls, but maintains some speed. So as opposed to going through a waterfall model where it just takes forever, or you know, an unextended period, we can still have a quicker deployment, but with more checks and balances. Is that?
Yeah. So that's the difference, is that, you know, because we have iterative builds and releases, the iteration really helps with things like, you know, other teams looking at your code while you're working. So you're not all in your basement doing something for 8 months before somebody can see it. It's very visible, and in that sense, the paradigm's completely shifted, because every 3 weeks you're producing something that has a lot of visibility. So while you're fixing just functional things, right? And that's what developers want to do. They just want to functionally get things working. There are other teams that can come in as early as 3 weeks into the project and start looking at other things, right? So.
Yeah, well, and we're going to beat it up more in the next module after the break, but we're using the terms functionality versus assurance. So
Right.
it's very important to give me a nice feature, but it's nice that that feature works well.
Right. Yeah. So.
Fantastic. Anything else for Barkha? And I had so many questions that I'm just going to save, but I mostly just want to say thank you so much, and I appreciate it. I wish you could come back on Friday. We do coding, but I think we've taxed you enough. This was great. I really enjoyed it. Oh, I know one other thing that just really bothers me, since you seem to have a lot of Azure experience. I've heard a lot of people who have to integrate Office 365 with Azure and say that, and very important to us is like federated identity management doesn't work well. That a lot of
so in some cases it is. It won't let you do all the hacky things that you could get away with in non-cloud environments. That's one way of looking at it. And in other ways, so it's a little more strict. So that's the other part of the cloud, is that some developers do find it very challenging because the policies just won't let you do things that you could get away with.
It seems like there's incompatibilities between libraries or something, that they're two separate, even though it's Microsoft, they're two separate groups that don't.
They are, and they're huge groups. So, but we do integration with O365 all the time.
Okay.
And I'm not going to say that it's straightforward. It's not. It's complicated, but it does work. And it's just that there's hoops that you have to go through because it's SaaS, and they're very particular about who has access to what and who can do what. So you really there's a lot of little gates that you have to cross before you can get it working. So, and we do it all the time. Our product is heavily integrated with O365, and that could be another class on its own.
But I'm sure it could.
Yeah, but it's complicated. It's not easy.
Well, thank you again.